So we will talk about our first topic, which is bivariate regression, right? So in this case, you will have two variables to work with. For example, let's talk about number of marks obtained in the exam versus number of hours you study. So in this case, we have two variables. One is marks obtained, okay, and other is number of hours you study. So can you tell me which is independent and which is dependent variable? So let's talk about two variables. Let's say you have hours, okay, hours you study and marks you obtained. So let's say you want to predict, okay, how much marks you are going to get in forecasting subject this year. Okay, how many marks you are going to get in forecasting subject this year. So if you have to forecast, the business problem is to forecast, right? To predict, to forecast marks obtained in final exam. Okay, you want to forecast. Okay, so to do forecasting, right, you need to know which all factors on which marks is dependent. Your objective is to forecast marks. So this is your dependent variable. You're focusing to forecast marks. You want to forecast marks. So marks becomes your dependent variable, right?
Yes.
So first thing you have to do is find out, okay, so this is your objective. Then to find out on what factors your marks is dependent. On what factors marks is dependent? So let's assume that marks is dependent only on hours of study. Okay. So for now, because we're talking about bivariate, right? Only one variable will take. Okay. Y is marks obtained and hours study is the X that we want. So we want to predict the marks obtained based on hours of study. So only hours of study has impact on marks. Okay. Okay. Now, second thing is to predict, we need to have past data, right? We need to have some data. So what you will do is you'll go to your senior, your senior who have already written the exam. Okay. Yes. And you will ask them, tell me how many hours you studied and how many marks did you get? So let's say, so they'll say I studied for 6 hours and I got 78% marks. Second student says I studied for 4 hours and I got 88% marks. One student will say I studied for 3 hours and I got 43% marks. 5 hours and 69% marks. 8 hours and 90% marks. Okay, this is hours per week, let's assume. Okay, then let's say another student says I studied for 12 hours and I got 93% marks. Okay, so you spoke to your seniors and you got this, right? So third step is obtain data. Correct? You need to obtain data. So you will look at various sources, right? So in this case, if you want to find out marks obtained, then you will go look at your senior. In some cases, you look at government website. Okay, if you want to predict about GDP versus car sales, right? So you need to check with the government data for GDP, car sales data from the car manufacturer. So depending upon your business objective, you will look for various data. You look for data from various sources. Based on the business objective, you will get data from various sources, right? So obtain data. The third step is to obtain data. Once you obtain data, then there are some pre-processing steps, we call it as pre-processing processing of data. What is pre-processing of data? Pre-processing of data means data cleaning, right? Before you use, you need to clean the data, correct? You need to clean the data, okay? After cleaning, you need to check if data, okay, or check if the independent variable actually impacts the dependent variable. Is there a connection? Is there a dependency of marks on hours? Okay, is there a connection? Can you really predict marks based on hours? So you have to check the data. Okay, so to check the data, there are multiple things you can do. First is using scatter plot. If I go to insert, okay, and I click on scatter plot. Okay, you can see my screen, right? I'm plotting scatter plot here. Farhan, right?
Yes, yes.
Can you see my screen?
Yes, yes.
So what I did just now, I created a scatter plot, isn't it? I created a
Yes, sir.
scatter plot here. Now, is this data, when you look at the scatter plot, what do you see? Do you see any kind of trend in the data? If you see, as number of hours increases on x-axis, your marks increases on y-axis. Correct? So you see that there is some correlation. That means it is possible to predict marks, okay, based on number of hours. So next step is plot. Okay, so if it is, okay, for regression, we plot which graph? Okay, for regression we plot scatter graph. So this is our scatter graph. Okay, and then look for trend. Positive or negative trend. Positive means, okay, correlation. I think you must have done in correlation. In correlation, positive trend means what? With increase in x-axis, the value on y-axis also increases. With increase in x-axis, value on y-axis also increases.
Also.
Right? So this is called positive relationship. In negative relationship, with increase in x-axis, the value on y-axis decreases. So in this case, what do you notice? As we increase that, plots are going up, isn't it? So this shows positive correlation between marks and number of hours we study. Okay, so plotting will tell us this. Okay, so we know the trend, but how to find the exact correlation value? Next is calculate correlation values. Okay, so to find correlation value, we have Excel function called Corel, C-O-R-R-E-L, Corel. In Corel, you give the one data and then you give the second data here. You see this? Okay, data 1 and data 2. And when you hit enter, you see you get a value of 68.5% or 0.68, right? So when you see 0.68, okay, typically if the value is between 0 and plus or minus 0.5, we say no correlation exists. Okay, so if the correlation value, okay, is between 0 and 0.5, minus or plus, okay, minus or plus indicates direction. It doesn't indicate any specific value. So plus means positive direction, negative means negative direction. But it doesn't tell you more than that. But value tells you how strong is the correlation. So typically between 0 and 0.5, we say that there is no correlation. Between, okay, plus or minus 0.5 and 0. Okay, again plus or minus, okay, plus or minus 0.7, we say weak correlation. So there is a weak correlation. So in this case, you see, this is weak correlation, isn't it? Okay, so what I'm saying is, okay, you need to find the correlation value. Okay, and I will give you the code for R and Python both. You can practice R and Python both if you want. But here, okay, let's do with Excel first, and then we can do with the other R or Python. So what I'm saying is, I want to see first, we plot the graph, and graph tells us, yes, there is some correlation between X and Y axis. The next step is to find the correlation value. Okay, next step is to find correlation value. What is the correlation value? Okay, to find correlation value in Excel, we have a function called correl. Okay, in the correl function, first we pass the first data set. So you need to find correlation between X and Y, isn't it? So first I'm passing the X value. So what is the X value? It is A2 to A7, correct?
Yes.
And Y value is B2 to B7. So I've said correl A2 to A7 and B2 to B7, and you hit enter. So now what happens? You get the correlation value here. Okay, you get the correlation value, and the correlation value is 0.68519. Okay, so how do you interpret this value? What does correlation value of 0.68 mean? How do you interpret this? So what it says is, if the value is between 0 and 0.5, we say there is no correlation at all. Okay, so if value of correlation is between minus or plus, okay, 0 to minus or plus 0.5, we say there is no correlation. That means based on, in this example, based on hours, we cannot predict marks. There is no correlation at all. Marks, it means marks does not impact, sorry, number of hours you study does not impact marks. If number of hours you study doesn't impact marks, then how can you find marks? That means marks is not dependent on hours of study, right? So Y is not dependent on X. If Y is not dependent on X, we cannot find Y. How do you know that there is a dependency? The correlation value has to be more than 0.5, first case. Second case, even if it is 0.5 and 0.75, we say weak correlation. Okay, so there is correlation, you can predict, but your accuracy will be very low. Your accuracy will be poor. Okay, to have a greater accuracy, the correlation value has to be closer towards 1. Okay, maximum value the correlation can take is 1. Okay, so here, okay, what you are saying is, if the value is between 0.75 and 1, okay, it is strong correlation. It is strong correlation. Okay, so in this case, our correlation is weak, our prediction, we will be able to predict, but it will be weak. We'll get a lot of error. So this is how you interpret a correlation value. Yes?
Yes.
So now that you know the correlation, next we need to predict the values. We will run the regression model. To run the regression model, we have to go to data. Okay, and you go to data analysis. See, if you do not have data analysis in Excel, you need to go to Excel options, okay, add-ins, and here analysis tool pack. You have to add analysis tool pack. Okay, it will take some time to install. Okay, if you already have it, you will actually see here the option data analysis. You click on data analysis. Okay, after click on data analysis, if you scroll down a little bit, you will see regression. Okay, so you're going to run regression now. I click on OK. Okay, so this small screen will pop up. Here we need to add all the information. Okay, so input Y range. What is Y range for us?
Marks.
Marks, correct? So which is B2 to B7. So you can type B2 to B7, or you can say click on this and go and select B2 to B7. Okay, what is our X range? Hours, A2 to A7, right? Okay, now confidence level is by default 95%. So when confidence level is 95%, that means generally, okay, we solve at 95% confidence level. P value has to be less than 0.05. Okay, now if you want, you can say all these. Okay, we want to see all this. We want to see result plot. We want to see line fit plots. Okay, and then new worksheet. Okay, it will create a new worksheet, sheet 4, and it will add the data. Click on OK. Did you get it? What happened? Okay. Yeah, it created all the metric for a regression. So what we just did is we performed linear regression on our data. We performed linear regression on our data. Okay, so it has given us a lot of data. So multiple R square, okay, standard error, observation. Observation is number of data points. So we have 6 values. So 6 is observation. Standard error. This is one other metric that we need to find out. See, so we have run the model. It has given, okay, so we'll talk about the metric later. Let's look at this first. This is the solution. This is the solution. Intercept 51 and X variable 3.94. Okay, how did we solve this? How did it solve? Okay, so see, we have marks, okay, which is directly proportional to hours of study, right? We cannot say equal to. Okay, so to make it equal, because marks is hours is impacting marks, to make it equal to, we have to multiply this with, okay, some coefficient, right? And then you do the constant value. Okay, this is how the equation will be formed. Okay, now this is also the equation for line. This is also equation for line. This is how a line is plotted, right? If you can put it in XY format, it is y equal to mx plus c. M is the slope, c is the constant. Y equal to mx plus c. Now, when you see this graph here, okay, this is a scatter plot with regression line. So blue points are the actual values, and these red points are the predicted Y. Okay, so it has done the prediction on the blue point. So based on the data, it is predicting that person who studies for, see here we have here. Okay, so first data is what? Okay, we can copy and paste the data point. Okay, so we can copy this here, actual marks. And now we can compare it. So what it says is if you study for 6 hours, based on our model, we are predicting that you will get 75% marks. But actually what is happening is, how much are you getting? You're getting 78. Isn't it?
Yes.
So this is the actual, and this is the prediction that is being made by our model. So what is the difference between actual and predicted? 78 minus 75.5, 2.48. This is the difference. You see this?
Yes.
This is the difference. Okay. This is the difference. So what it says is this is the input number of hours you study. This is the actual marks that we got, and our model is predicting this one. Now, how is this model predicting? Model is predicting because model has found this equation. So what this equation says is y equal to coefficient of this. So coefficient of this is 3.94. So in our case, y will be 3.94 x plus, what is the intercept value? 51.8. It is 51.8. Now, based on this, you can predict any marks. Okay. So now let's try to predict our marks. So let's say you can write your friend's name. Okay. And this is the hours of study. So you ask your friend, okay, how many hours do you study? They will say, I'm studying 8 hours. Some will say 9 hours. Some will say 13 hours, 11 hours, 14 hours, 16 hours. Okay. So you will say, this is what I predict. So you are predicting into M plus C. So you are saying that you are going to get 83% marks. Okay. This person is going to get 83% marks. Do you understand how we have calculated this?
Yes, sir.
Okay. Let me make it fixed here. So F4, oops, F4, why is it moving? Okay, manually let me put. So to fix this, we have to say $B, $8, and $B, $17. Now I can copy and paste. Sorry. C. Okay. So of course, maximum marks is 100. So anything more than 100, you will round it off to 100. In this case. So this is how you are predicting. So now you are able to predict the data, right? So you run the linear regression. What did we do? We run the regression model. Okay. So run the model and look for coefficient and the intercept. Okay, so if you take this, okay, and let me put it on paint here. Okay, So the regression line is the best fit line that passes through, okay, all this data, that represents all this data. So in this case, our regression line, okay, would be something like this. Regression line is the line that actually predicts. Okay. So this is the regression line. So this line represents all the values, all the dots here, all the values. And intercept is nothing but this value. So this is the intercept value. Okay, this is how we represent intercept value. And your M is slope. So M is nothing but, if you take this line, anywhere if you draw a perpendicular line to this, so y by x, okay, this by this is your M, slope. Okay, so anyway, our model Excel or R or Python will give us these values. So here you run the model and look for coefficient intercept and form the equation. Y equal to your coefficient into x plus the intercept. Okay, and then next step is to predict the data. Now you put whichever data you want to predict, take the new data and put that in the equation above. Okay, and you will have your new value. Yes?
Yes.
Okay. So this is the steps that we perform. Okay, find the factors, obtain the data, process the data, make it data ready for the analysis. That data could be missing, data could be wrong, so you are fixing it. Then you are plotting the graph. So in regression case, you are plotting the scatter plot. Then you are finding the correlation values to see the the cause and effect relationship. Okay, so why do we do the correlation values? To find the cause and effect relationship. Is it really getting affected by the marks? Is it really getting affected by the hours of study? Okay, if it is more than 0.75, it is strong, 0.75 or 0.8, that means your error will be less. But if it is between 5 and 0.75, it is weak correlation, but still you can find, but error will be higher. Okay, if it is less than 5.5, then you will say that since the correlation is not there at all, linear regression will not help us to predict the value. Did you get it?
Yes.
Then if you are confident about the correlation value, you run the model. You can run the model using Excel or R or Python. Okay, so we just ran using Excel, and these are the values that we got where in sheet 4. So what is important here to predict is this coefficient values here, intercept and variable 1. Okay, so this point is the predicted value. The blue one is the actual values. So we are predicting for each of these values. So you get this. Okay, now in this equation, you pass any new value, you will get the predicted value. Yes?
Yes, sir.
Last step is to evaluate. How do you know how good you have worked hard, but how do you know whether the model has performed right job or not, did right job or not, right? So see, we have multiple algorithms. Like linear, okay, polynomial, SVM, ridge, lasso, elastic net, okay, decision tree, and many, many more. Okay. So how do we know which model is best? Okay. So there are many metrics. The effectiveness of model. Okay. Top three. We'll talk about three. Okay. One is the standard error. Then you have the t-stat value, t statistics, and a p-value. And the third one is your r-square value. So these three are the three important metric. Okay, we have even more than this, but generally we look at these three values. So when you say error, error has to be less or more. Error has to be less or more.
Less, sir.
Error has to be less or more. Error has to be less or more.
Less, sir.
Less, yes. Error has to be less. So error closer to 0 is better. Okay, the value can range from anywhere from 0 to upward. Okay, 0 means there is no error. Okay, so if you have to compare two models, the model which have lesser standard error is better model. Yes. Second thing is t-statics. T-stat value has to be higher than 0. Okay, more higher it is, more confident we are about our prediction. Okay, and p-value, okay, in case of 95% confidence, okay, p-value has to be less than 0.0, 0.05. Okay, it has to be less than 0.05. Okay, and the third is r-square. R-square again will range from 0, worst fit, to 1, which is best fit. Okay, R-square should be closer to 1. So when you're comparing two models or three models or five models, let's say you have you want to compare models. Okay, you have linear regression, SVM, okay, decision tree, okay, random forest, you know, ridge, okay, the ridge. Okay, then you look at r-square value. You look at t-stat. You look at p-value. You look at standard error. Okay, and then you compare. Okay, r-square should be what? Closer to 1. Standard error should be closer to 0. T-stat should be higher. P-value should be 0. So these two so these values have to be closer to zeros. So these values have to be closer to zeros, and these values have to be closer to higher, should be higher, right? So r-square should be 1, t-statistics can be very high, p-value should be 0, standard error should be 0. I mean, not 0, but closer to 0, less than 0.05. Now let's go and compare our model, how well we have done. So see, p-value is 0.13. It's not less than 0.05. That means the model that we have done is not good. Yes? So data set is such that linear regression model may not work well here. Linear regression model may not work here. Did you get it?
Yes.
Okay, so p-value has to be 0. So in this case, we are not confident. Okay, the value that we got, okay, is not so good. So this data set may not be predicted well with linear regression. We have to use some other model. Definitely not linear regression. Okay, now let's look at other thing. Standard error will be upward. Standard error is 15. Okay, it has, so generally we compare with the average of y and this. Okay, if average of y, if you take it, maybe it is around 65, 70, right? So it is 15. This should be closer to 0. This is also high. R square should be 1, but it is less than 0.5. So all the metric in this case are not good. That means this data set is not good for linear regression models. Okay, we have to use some different model. In your syllabus, you only have linear regression. Logistic regression is for classification type. We'll see later. But you have only linear regression. But in future, when you are talking about models, okay, this is how you evaluate the model. This is what we just did. Okay, so we have hours and marks, and we have drawn the linear regression model. Okay, and this tells us how well is the model. Okay, so there are other examples. Go through this video and try to practice these examples again. Okay, so this is what we did: modeling the problem. Okay, then estimating the coefficients, right? So once you estimate the coefficient, then we need to analyze the coefficient, how well our regression model has worked. Okay, so then you look at the quality of forecasting. So you have standard error, t statistics, okay, p-value, and R square is also called as coefficient of determination. R square is also called as coefficient of determination. Okay, and these are other metric that we can use to predict. Okay, so with this we end our bivariate discussion. Okay, if you want to perform another example, let me take another example and let's do it. Okay, so I'll take this. So we are trying to predict the heart rate based on the age, right? So let's try to predict the heart rate based on the age. Okay, so I'll copy this data here. Okay, so you have 18, 51, 57, 59, 55, 67, 68, 64, 71, 67, 72, 70, 75, 71, 69, 79, and age is 75, 71, 68, 56, 53, 49, 45, 39, 36, 30, 29, 28, 24, 20, right? So this is the age and you have the heart rate, right? So let's draw the scatter plot to see how well this data is working. So yeah, this is the scatter plot. So we see there is a trend here. So probably, okay, we can apply linear regression model. So let's try to see the correlation value. Coefficient of correlation. Okay, so correl And this is the first data set. And this is our second data set. 0.8. So it is strong correlation. Okay, there's a strong correlation. Now we can run our model here. So I'm going to data analysis, regression, okay, and the range here would be, okay, we're trying to predict heart rate. So heart rate will be the Y data set. Okay, X data set is going to be age. Okay, then let's run the regression. Now you see here, the equation is Y equal to 0.33x plus 51.9. This is the equation. Okay, and here R square is 0.66, better than the last model. Okay, still not very good, but 0.67 is still better than what we had last time. Okay, P is 0 less than 0.05. So P is something which is good, and T statistics is also good, right? It is 5. So our P and T statistics are good. Standard error is 4.7. So if you compare to 60 and 50, it is 4.7, right? So this is also better than our previous example. Okay, so using this model, you can predict the heart rate for any age group. So if you want to predict the heart rate for say 29-year-old, right? It's going to be 29 into 0.33 plus 51.9. Okay, so 61 is what we expect the heart rate of someone who is of age 29. Okay, so this is how we actually use in a regression. So I've done this third one also. So you can practice other two and go through this content, read this content. Whatever I've just said, everything is explained in the words here. So read through this. Okay, tomorrow when we meet, we'll talk about multiple regression or multivariate regression. Okay, so with that, we'll end for today. Take care, everyone. Bye. See you tomorrow.